The universe, vast and ancient, has a beginning we've traced back to a fiery birth, the Big Bang. But what about its end? Will everything freeze in eternal stillness? Collapse in on itself in a cosmic reversal? Or could the universe end in the most violent and unsettling way imaginable? A tear through the very fabric of space-time? This is the hypothesis known as the Big Rip. It's a theory not of decay or collapse, but of total disintegration, where galaxies, stars, planets, and even atoms are pulled apart by an ever-accelerating force we can barely comprehend. It is a vision of cosmic death driven not by fire or ice, but by something far stranger, dark energy. Today, we explore this radical possibility, a journey into physics, time, and the ultimate fate of everything we've ever known. To understand the Big Rip, we must first confront one of the greatest mysteries in cosmology, dark energy. In 1998, two independent teams of astronomers were measuring the expansion rate of the universe. They expected to find that gravity had been slowing it down. Instead, they discovered something astonishing. The expansion of the universe is not slowing, it's speeding up. The force responsible for this acceleration? Dark energy, a term we use more out of necessity than understanding. We don't know what dark energy is. We only know what it does. It pushes, relentlessly. It's not like gravity. It's not even like dark matter, which clumps and pulls. Dark energy is smooth, uniform, and fills the vacuum of space itself, making more space, more quickly, as time goes on. It currently makes up around 70% of the entire universe. And here's the strange part. As the universe expands, dark energy becomes more dominant. Because it's not diluted by expansion, it thrives in it. This is where the Big Rip begins. The universe has been expanding ever since the Big Bang, nearly 13.8 billion years ago. At first, this expansion was rapid, a burst known as inflation. Then it slowed down, allowing matter to clump into stars, galaxies, and planets. But over the last few billion years, something shifted. Dark energy took over. Now, every galaxy not gravitationally bound to us is moving away, faster and faster. Space itself is stretching between them, and there's no friction, no resistance, no cosmic brake to stop it. In our current model, the universe will continue expanding forever, leading to a cold, diffuse heat death where all matter fades into irrelevance. But what if dark energy doesn't remain constant? What if, instead, it grows stronger? That's the key idea behind the Big Rip. Not just a universe that expands, but one that accelerates exponentially until the very laws of physics can no longer hold things together. It is not just a future of loneliness, but one of destruction. If dark energy's repulsive force continues increasing, if its energy density grows without bound, the expansion of the universe will accelerate to catastrophic extremes. In the final billion years, distant galaxies will vanish from view entirely, not because they explode or collapse, but because the space between us and them is expanding faster than light can cross it. They will literally be pulled beyond our horizon, erased from our reality. A few 100 million years before the end, galaxy clusters will start to drift apart. Then individual galaxies, like the Milky Way, will be ripped from their satellite companions. Gravitational bonds that held them together for billions of years will snap like threads under pressure. A few million years from the end, solar systems will unravel. Planets will break free from their stars. Earth will no longer orbit the sun. Even as life likely already perished, the structure of our solar system itself will disintegrate. Hours before the end, stars will be torn apart, their fusion processes disrupted as the forces holding atomic nuclei together are overcome. White dwarfs, neutron stars, even black holes, all will be vulnerable. And in the final fractions of a second, matter itself will begin to unravel. Molecules, atoms, protons, even the quarks inside them, all ripped apart by a universe that is expanding faster than the speed of causality. This is the Big Rip. Not a bang, not a fade, but a tear through everything. The Big Rip is a theoretical outcome, grounded in physics but extrapolated to the extreme. It depends on one critical factor: the nature of dark energy. If dark energy's density stays constant, the universe will continue expanding forever, but structures will remain intact. If it decays over time, expansion might slow, even reverse. But if it increases, even slightly, the Big Rip becomes not just possible, but inevitable. Physicists model this behavior using an equation of state, a number called W. If W equals -1, dark energy behaves like a cosmological constant. If it's less than -1, dark energy becomes phantom energy, the kind that causes the Big Rip. Right now, observations suggest West is close to -1, but we don't know for sure. Future space telescopes and experiments aim to pin it down with greater precision, because the fate of the entire universe may hang on that single number. The Big Rip might be billions of years away, far beyond the lifespan of our species, our planet, and possibly our galaxy. So why does it matter? Because studying the end of the universe helps us understand its beginning. The more we learn about cosmic expansion, the more we understand the fundamental forces shaping our reality. It also challenges our assumptions about permanence. We like to think of space as empty, as nothingness. But the Big Rip suggests that space itself is dynamic, alive, and potentially dangerous in its silence. And it reminds us how little we truly know. Dark energy makes up most of the universe, yet remains one of the least understood aspects of modern physics. To explore it is to touch the edge of knowledge itself. Cosmic endings are hard to grasp. They occur on timescales that dwarf our own existence, in forces that operate beyond all intuition. But they also invite humility and wonder. The Big Rip is one of the many possible fates that await our universe. Others include the Big Freeze, a slow drift into entropy, or the Big Crunch, a dramatic reversal of expansion. There's even the Big Bounce, where the universe may collapse and explode again, endlessly. But the Big Rip is perhaps the most terrifying and awe-inspiring, because it suggests not just the death of stars, but of the laws that bind matter together. It is a reminder that nothing, not even atoms, are guaranteed forever. And in that realization lies both fear and freedom. We are tiny beings, living on a fragile world, orbiting a common star, in one galaxy among trillions. And yet, we are capable of imagining the end of the entire cosmos. The Big Rip is more than a theory. It is a meditation on time, on fate, and on the power of human curiosity. Whether it comes to pass or not, it teaches us something vital, that the universe is not fixed or static, but alive, changing, and always moving towards something new. And perhaps, just perhaps, in studying its end, we come closer to understanding our own place within it.